Alright, so hopefully you guys tried them out. And then in this video, we're going to try questions 1 and 2 out when it comes to, okay. So it says 10 light bulbs were tested to see if the voltage age worsened. They had, the standard deviation was 0.15 volts. Construct a 98% confidence interval to estimate the population standard deviation of all voltage levels. So again, right, when it came to the last couple sections, the question tells you exactly what they want you to do, right? A population for standard deviation. So the other one said mean, proportion, right? This will literally play out to tell you again standard deviation. Okay. So in this case, we need a couple of things. So n in this case is going to be 10. Alpha is going to be 1 minus 0.98, which is 0.02. Okay. And then S is going to be 0.15, right? Sample standard deviation. All right, so now we do the same thing we did for the last example. We want to find our two chi-squared values. So again, right, since we want alpha over 2, I divide this number by 2. It's going to be 0.01. And again, I'm just going to cross this out because I'm never going to use that again, right? So now we go back to our table and we could find both chi-squared values. So degrees of freedom in this case is going to be 10 minus 1, which is 9. So alpha being 0.01 and degrees of freedom of 9, let's see what we get. So 0.01 and degrees of freedom of 9 should be 21.666. Okay. And now we do the same thing on the other side. Well, this time again, right, we have to do 1 minus it. So 1 minus this number should give you 0.99. So I'm doing the same thing, being now alpha being 0.99 and degrees of freedom of 9. This chi-squared value on the left-hand side should be 2.088. Okay. And now at this point, right, we plug it into our calculator and break it down individually. So first is 10 minus 1 times 0.15 squared, all divided by 21.666. And on the other side, it's almost identically, except we divide by the other chi-squared value. Okay. So in this case, you should get the numbers of roughly 0.097, and the larger one should be 0.311 as your confidence interval. Okay. And again, right, the last thing is to interpret. So I'll just say it for you guys. We can say we are 98% confident that the population standard deviation of all voltage levels is between this number and that number. Okay. So that is question 1. Okay. So now let's go on to question 2. So question 2 says, let's see if I can raise this a little bit better. Okay, so question 2 now says, the following data represents the age in weeks at which babies first crawl based on a survey of 12 mothers. The data is normally distributed with an S equaling 9.66 weeks. Construct and interpret a 95% confidence interval for the population standard deviation for the age in weeks at which babies first crawl. So again, right, it's told us to construct a confidence interval for the standard deviation. So we need a couple things. So S in this case is 9.666. And, well, how many patients were there? So a survey of 12 mothers, so N is 12. And alpha in this case is going to be 0.05, right? 1 minus 0.95. All right, so first off, we got to find degrees of freedom. So that's going to be 11 in this case. And now what is alpha over 2? So cut this in half. It can be 0.025. And again, I'm just going to cross it out because I'm not going to use that anymore. Okay. All right, so again, if we find our chi-squared values, so again, this is going to be 0.025 with degrees of freedom of 11. You should get a chi-squared value of 21.920. Okay, and then the other one, so 1 minus this value should give you 1. Should be let's see if I can see that. I don't know if it's going to be. Let's try to. Let's see if that works there. So 1 minus this value. I like how that looks. Go a little farther. Okay, so